Hello students, let's take a look at how we deal with vectors. We're going to do vector addition and we're going to use the factor label method. There won't be any music for this video. The software is not working right now. There's a few ways that we can add vectors together, but we're going to use the factor label method. When we have a vector, we draw a vector with an arrow. This is a new software. So the vector we draw with an arrow. This is the tip, and then the tail is over here. And so we just take and we move vectors from tail to tip. If I have a vector like this, vector A, and I add it to this one, we'll call this vector B, I can take the vector and move it anywhere. I can take vector A and I can put it over here. So I'll redraw A, and then I'll take vector B and I'll take the tail of B and I'll put it to the tip of A. I keep it the same length and I keep it going in the same direction. The first one started at this position, the last one ended here, and this is the result that I get. We put R because R stands for resultant. You can add vectors in any order. You can add as many as you have. So if I had vector A this way, and I had vector B going this way, I would still do the same. Vector A I would rewrite, and now I would take vector B, the tail here, and put it to the tip here. It would go this way. So this would be vector B. The first one started here, the last one ended here. So now our resultant is smaller. You could also think of these as like positive and negative numbers, right? If this represented a 5 and this represented a 3, then the resultant would be 8. If this were a 5 and this were a 3, then the resultant would be a 2. You can also add vectors that are not in the same direction. So if I had, again, vector A this way, but maybe vector B is perpendicular to it, we would still write vector A the same way, and we would do the same as before. Now we're going to take this vector and we'll move it exactly over here facing in the direction that it's pointing. This would be B. So A started here, it ends up here. That would be the resultant. And you can add as many vectors as you have. We'll do one more example here. Vector A, vector B, and maybe we have vector C this way. So we do always tail to tip. There's A. B is this way. C is over here. First one started here. Last one ended here. This is our resultant. And we can even do numbers too when we have different angles. Let's say, just for example, that this was 3 and then this one was 4. We know the resultant would be 5. You can use Pythagorean theorem, or you can use your 3, 4, 5 triangle trick. We could do the same thing for this last example, but we're going to skip that for now. It's a little bit more complicated. It's manageable, but not for our class. If we had an example like this, we've got two different vectors. Now they're both starting from the plane, but we're not going to draw them that way. We can label the one that's forward, that's the plane vector. And then we also have the wind vector. So if I did part A here, I can draw the plane vector this way. The wind vector, tail to tip, goes that way. The resultant, first one here, last one here, this is the resultant. For part B, plane is still in the same direction, but now the wind has that angle. The wind is going like this. First one starts here, last one here. That would be our resultant. Part C, plane vector. Wind vector goes this way. First one here, traces all the way around, last one ends here. This is our resultant. We'll do the last one. Drawing the plane vector, wind vector here. First one starts, we follow all the way to the end. This is our resultant. And we can add as many as we like. In this case here, there's only two vectors. There's the plane vector, the plane's velocity, and the wind vector. This would be a crosswind. These are also crosswinds. This has a tailwind, headwind, that's another tailwind. You don't want to land if you have a tailwind. The last thing that we'll look at is that sometimes a resultant is already given. So that's what these are. These are all R. And what we want to do is we want to find, well, what are the components of the vector of that resultant? In other words, what do we have to add to get R? The way that we do that is we just drop down a line. I'm going to do a dotted line to each axis. And where that perpendicular line that we've drawn hits the axis, that will give us the components. So this line here, that's the x component of our resultant. This is the y component of our resultant, because this is on the x-axis, and then this one is on the y-axis. We can do the same thing for the others. Just continue that up here. If I drop a perpendicular line straight down and straight across, where it meets is our component. So that's the x component in this one. It's a lot shorter than the previous example. This side here, this is the y component for this resultant. The last one, we'll draw in our axis. Dotted line, perpendicular, perpendicular. And then where that perpendicular line meets our axis, that tells us where the component is. So for this last one, we have this longer x component because it's on the x-axis. We have this short little stubby y component on the y-axis. So give it a try. These are just some examples of how we can use the tail to tip method for vector addition. And I will see you in class. Sorry, there's no music.